Population forecasting and flow rate estimation. 1. Population forecasting. Population forecasting means calculation of the future population. To calculate the future population, we have two models, linear model and exponential model. Linear model, Pn equals Pi times 1 plus Nr. Exponential model, Pn equals Pi times 1 plus R to power of N, where Pi is the population at year I, Pn the forecast population after n years, n number of years, R the average annual population growth rate during the design period, %. Example 1. In current year, 2021, a residential area of 200,000 inhabitants. Estimate the population for 20 years of design period if the assumed annual population growth rate is 3%. Use the linear and exponential models. By using the linear model, P20, because n here is 20 years, it is the design period, equals Pi. Pi is the current population in the current year, times 1 plus n, 20, times 0.03, which is the population growth rate, equals 320,000. By exponential models, P20 equals 200,000 times 1 plus 0.03 to power of 20 equals 361,222. Now we have to explain this. If we haven't the current population in the current year, but we have the population before 10 years, for example. Here, the example 2 will explain this problem. If current year 2021 and in last census that carried out before 10 years, a residential area of 200,000 inhabitants, estimate the population for 20 years of design period if the assumed annual population growth rate is 3%. Use the linear and exponential model. Here the difference with n. N here equals 10 plus 20, so 30. P30 equals 200,000 times 1 plus 30 times 0.03 equals 380,000. And by exponential model, the result 485,452. See here, always the exponential model result is higher than the result of linear model. Flow rate estimation. Here we have to say the population forecasting is not the purpose itself, but the purpose is calculation of flow rate. So Q wastewater equals Pn, this is the future population, times Q wastewater, where Q capital wastewater is the wastewater flow rate after n years at the end of the design period. And Q wastewater, Q small, is the wastewater flow rate produced by one person, liter per capita per day. Example 3. Calculate wastewater flow rate for a residential area mentioned in example 1. If Q small wastewater equals 100 liter per capita per day, use the result of linear model. Q wastewater equals Pn times Q wastewater equals 320,000 times 100, which Q small ww, divided by 1,000 to convert to cubic meters. The result is 32,000 cubic meters per day. So the population forecasting to use here just to calculate the flow rate. If we haven't QWW, the water consumption QW can be used. So Q wastewater equals QW. This just in the treatment plant design. In the design of wastewater treatment plant, the average sewage flow rate is usually about the same as the average water used in the community. But in the design of wastewater collection network, generally 70 to 80% of water consumption is taken as wastewater flow. Water demand forecasting. Here we can use the same models to calculate the future water demand. Qn, which is QW, equals Qi times 1 plus Nr, and exponential model like this. But here the difference is R. R, the average annual demand growth rate. But in the previous equations, when we calculate the future population, R was the average annual population growth rate. Population, not demand. But here, R is the average annual demand growth rate during the design period. So when we calculate Qn equals Qw, we can use it as Q wastewater.